Hi class, welcome to Pandemic Physics. I'm Professor Close, and today I'm going to teach you about standing waves. We're going to start off with a slinky, a long spring. I've got it tied to the chair on one end, and I'm going to hold it 6 feet away on the other end, which is 183 centimeters. And the first thing we need to do is measure the speed of the wave on this spring. So I'm going to do that by putting in a disturbance, and then we're going to measure how long it takes for that disturbance to propagate down and back 2 times. Okay, ready, go. 1, 2. Okay, did you catch that? Okay, so let's go on. Next thing we need to do is generate standing waves. Each standing wave will have nodes on the 2 ends and antinode in the middle. Okay, so let's start here with what's called the fundamental frequency. Okay, so that's going to be just up and down motion. Try not to hit the floor. Okay, so there, that's an up and down motion. So count 10 cycles and measure the time for 10 cycles. Okay, ready? Go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that was 10 cycles. That's called the first harmonic. The second harmonic is going to have a node in the center and then 2 antinodes. So let's see if we can get that one going here like that. Again, count 10 cycles. Ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pretty fast, huh? Okay, so that's the second harmonic. And let's see if we can do a third harmonic, which should have 3 antinodes. Okay, well, that's a little too many. How about there? That looks like it. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, let's try that again. Ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's the third harmonic. And let's see if we can do 4. That looks, should have a node in the middle there. That looks like it. Ready? Oh, lost it. Okay, got a node in the middle there. That's it. Ready? Go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got it. Okay, so those are standing waves with 2 ends fixed. The end I'm holding I shake a little bit, but compared to the rest of the spring, it's barely moving. Okay, and let me show you another type of standing wave. This one's going to have one end fixed, which I'll be holding, and the other end will be loose down there by the floor. Okay, so this kind of wave, it's a little different. It's going to have a node on one end and an antinode on the other end. And you can actually just make a wave by swinging it in a circle. That may not look like a wave to you, but it's actually a wave. It's got node on the top and antinode on the bottom. So let's count how long it takes for that to make 10 cycles. Ready, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's 10 cycles. You can go back and look at that, measure the time, and determine the frequency. Okay, so now if we do this faster, we should be able to get a node about a third of the way up the rope. Okay, and so we'll have 3/4 of a wavelength on the rope instead of before was just 1/4 of a wavelength. Okay, so let's try that, go a little faster. See, there's a node down there on the end. So ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so quite a bit faster. And then let's see if we can get 2 nodes in there. There it is. Ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, got it. Okay, so take those data and do a little analysis and you should come up with some interesting data on standing waves. All right, bye.